Okay, my next demonstration here is that we have some presentations to follow. I would like to open these presentations and just basically go through them. But at this point, all I want to do is just go to cpp.shell, C++ shell, which hopefully, if it's available, we can use it. If not, we can switch over to basically a compiler, that whatever compiler is available to us. By the way, to give you a head start, I am planning to use code blocks, which is available on pretty much all platforms. So yeah, so apparently CPP shell is quite popular and not currently available. That's okay. You all have Microsoft Visual Studio 2013 on your desktops. You can use it if you'd like. For those people who are watching those recordings at home, I'd say right now my plan A was to use CPP shell online, but I begin to sense that maybe next week I'm going to move it a little closer to the beginning of our semester, that we can install code blocks and use it as our essentially open source platform to access the compiler and do our exercises. So at this point, without wasting any time, try finding Visual Studio 2013 on your desktop, or just type it in your search box if you'd like to follow along with what I do. I'm just going to start Visual Studio, which is installed obviously on my system here, and I'll use it for today's demonstrations. So I have a plan in mind in terms of what I would like to go over today. Let me just show you again one more time how you would create a new project. If yours already started, yours may be taking a little bit longer time.
It sucks that it's so unstable.
Yeah, it may be unstable, so today I'll just revert to using this Visual Studio, which is a desktop compiler. But if CPP SH already running, that's fabulous. You can just use it. Yeah, sometimes you can have those glitches, and that's fine. So what I'm going to do in Visual Studio is just say new project. And I'm going to go relatively fast today because you can watch the recording if you really need to know what to do. Right here, this is a Microsoft product. So make sure that you point to Visual C++, number one, in terms of the template for your project, and simply find, as soon as you can find it, just do an empty project. That's all I want you to do, is just to do an empty project. Now, in most cases, so today this is going to be, the name of the project is going to be week 2 demonstration, right? And occasionally I'll be maybe saving some code that I can post. Make sure that you choose some kind of location where you can find your project, especially if you have Visual Studio installed. But for us, it's just going to be mostly just a throwaway 2-3 line of code experimentation. So nothing really scary or too serious. Everything that we do, you should be able, and we can occasionally check with CPP SH. You just click OK after that, and it's going to create us an empty project, hopefully, right? And in that empty project, we're going to do some experimentation. All right. So if yours may be looking a little bit more crowded than what I have, okay, but I routinely close all kinds of panels and windows in this environment when I need to do my work. So normally, first thing to do is make sure you click View Solution Explorer. That's basically a little like tree view panel or browser for what we have included in this in this environment, and it's actually empty because we created an empty project. So make sure to highlight source files, right click and say add new item, okay, if you'd like to follow along, and highlight C++ file. Remember, C++ compiler includes for the 99% of it, includes C, all C library, all C syntax and rules. So therefore, essentially, C++ uses C programming language as a subset. So therefore, it's nothing to be scared about to open a C++ file, and you can actually write strictly C code in it. In terms of the name, down here it wants the name. And it says source CPP. I'm going to rename it as main.cpp because main.cpp is a very typical file that I'd like to have in all of my projects which have a public entry pointing to this program. I'm also going to add, to simplify things a little bit, I'm also going to add src at the end of this path to keep my source files in a separate subdirectory. I'll open this location for you in a second to show you what I really mean. So I'm just going to click Control-C to copy and click Add, okay? So what just happened is that I added this main CPP file right here. It's blank. It just opened in my source editor, and like I promised, if we go here and if I go to to this location which has this path, Igor junk week 2 demo source, you can see there's a main CPP file and its size is 0. It's empty file. It has nothing in it, right? So if I go up to my project name directory, you can see that there's like all kinds of junk that Visual Studio creates. Like this is the database of cool prompts that it can make, completion of typing when you write your code. This is the actual solution file. This is the project file, and there are also options that are available with that. So we don't worry about those. We routinely kind of ignore them. But the source file is there. Of course, when we write code, when we write programs, they're all just text files. Okay, all right, here. Let's just test everything. The smallest program that you can possibly have is this: int main, and then curly braces, and then a return 0. Okay, so that's the smallest. Let me resize this so you can see it better on your screen. This is the smallest program. I can compile it, build solution. Right, just do that, and this is your option to build. Just build solution, or you can press F7. It builds, and what you should see at the end is that it was a successful build, and there were no bad error messages or anything like that. Again, your display may be a little different than mine, but in general, just watch out that there aren't really any ugly errors when you do this. As you can see, we use curly braces, of course. By the way, let's talk about this a little bit. If I think I told you the first day when I have this, let me just resize this, maybe make it a little bigger. No, it doesn't want to, so I'll use what I currently have, right? When I have this main program right here, okay, when I have this, I wish this was a larger font, but I'll ignore it for now and stay with what I have. Main right here, okay, this is called a function. Okay, this is a function. Function has a name, so my function name, right? My function name is main. Main is a public entry point into the program. because it has the special recognition that anytime you need to make your program runnable, you have to have a public entry point into that program so that when it's loaded for execution, it knows where to start. And in our case, the name of that function is main. What is a function? Function basically is a placeholder for any executable stuff, right? In your code, any executable stuff. So if you want to do like 1 plus 2 multiply by 6, this is where it's going to happen. It's going to happen someplace inside a function. So function is basically a logical placeholder for actions, for executable stuff that you want your program to do. Okay. Another example could be create a window, display a text box, populate that text box with some value. All of these are examples of executable actions, and they have to be sort of like hosted, placed inside a function. Now you see that there obviously these curly braces right there, so let me sort of like make them a little larger for you, like that, right? A little larger so you can see them better, these two braces. So essentially they create this enclosed area between these two braces. Okay, enclosed area, which we can call, from the function perspective, this is called the body. The body of the function. Let me just do a better job. Body of function, or simply function body, and we're gonna have to refer to the body of the function whenever we talk about what it actually does, right? So function name is like a little header. And do you know how compiler knows that main is a function? Because it has a set of parentheses, opening and closing parentheses. This is like basically saying main is a function. That's how compiler interprets these opening and closing parentheses. Function also has something we call a return type. Okay, a return type. In our case, the return type is here. This int, which stands for an integer, is our return type. Okay, so in our case, return type is int. What it means on most platforms, that the function returns a number back to its caller. Who do you think is the caller of this function main? It's some component of the operating system, right? And there is an operating system that will be running this program. Main so far is the only function that we have, and it can be invoked. At the end of its execution, this function promises to return a number back to the caller. The type of that number is int. When I think about int on most platforms, it's actually 4 bytes in memory, and it's 32 bits of zeros and ones, right? But normally, when you return, you want to return 0. Okay, so if we return 0 like we do over here, okay, just like we do over here in this, it just like gives me trouble with some smart attempts to make it easier to use this environment. But what it means is 0 means okay. All right, so okay means everything is great, and returning 0 from someplace really represents a very successful ending to this affair, right? So this was a good experience. Main ran, everything was good, and we signal 0 as success, right? Okay, or other word for it would be a success. Okay. Now, otherwise, if it's not 0, typically it can be interpreted by someone else, whoever invokes this function, as an error code. And typically you would like to read your operating system documentation or your platform documentation to find out what typical error codes are. For instance, a failed attempt to open a file would be decimal code 15, okay, on many systems. And likewise, you can have other errors, okay? Not enough memory, there'll be another code, and so forth. Okay, now you see that actually, let me switch to the compiler because we pretty much went over all of these little components of main. This also is not a bad display of everything. Return, which is, you can see, is a highlighted keyword printed in blue because source editor wants to kind of like give us those nice hints, whatever is the reserved word. So return is a statement. If you're taking your Java course, you already know that you can recognize statements by looking at their ending with a semicolon. It's an absolutely sure thing to know that if you have something that looks like this thing I have, return 0, semicolon at the end indicates that this is a statement. And return is basically your ability to tell the compiler, okay, see this return statement, see this 0, this is the value I want you to return back to the caller, whoever invoked main. Of course, compiler has no idea who's going to be invoking main. Main, on the compiler standpoint, is just a function, okay? So someone else, or as our linker, typically a linker utility, makes it really a well-recognized public entry point into the program. But from the C compiler standpoint, main is just a function, okay? Which has no input parameters, which would otherwise be specified right here between those parentheses, returns integer, and it has this return statement which actually does return 0 to the caller. Now, of course, main is not the only function that I can have.